Hello friends, welcome back. Hearty welcome to you. We are going through slope of a line as part of coordinate geometry. So we have some examples to do. Let's do them together. The first one, show that the line joining the point 2 comma minus 3 and minus 5 comma 1 is parallel to the line joining another 2 points. So we have 2 points by which you can have one line segment. You also have another 2 points by which we can have another line segment. We have to show that these two line segments are parallel to each other. We are dealing with slope. So how we can prove that two line segments are parallel to each other is if they are having the same slope. So what we know is if m1 is the slope of a line and it is equal to slope of the other line m2, then we know that the lines are parallel to each other. The lines or line segments are parallel. Similarly, if m1 is slope of a line and m2 is slope of another line, and if their product is nothing but equal to negative of 1 or minus 1, then the lines are perpendicular to each other. Lines are parallel here, the lines are perpendicular to each other. We'll leverage these two simple formulas to solve these examples. What are those formulas? If two line segments are parallel to each other, then their slopes are equal. If two line segments are perpendicular to each other, then the product of their slopes is nothing but equal to negative 1. Okay, so let's go ahead and do that. Let's go. Here we go. The first one. Show that the line segment, we have just gone through that. Let me just put down the points. One point is 2 comma minus 3. So another one is minus 5 comma 1. This is one set we have. Another set we have is 7 comma minus 1. That's a point. And we have 0 comma 3. So let us say this is A, B, C and D. We have to prove that slope of AB is equal to slope of CD. So let's find out the slope of AB first. Slope of AB goes by the formula x1, y1, x2, y2. Slope is always change in vertical distance divided by change in horizontal distance. That's nothing but delta y by delta x. y2 minus y1. So 1 minus of minus 3 by x2 minus x1. That's nothing but minus 5 minus 2. This is nothing but equal to 4 divided by 7 minus. So minus 4 by 7. If I look here, y2 minus y1 is 3 minus of minus 1 divided by x2 minus x1. That's nothing but 0 minus 7. That's equal to 4 by 7 negative 4 by 7. You can see that both the lines, the slopes are same. Now what is the meaning of slopes are same? Let's try to have this small picture and see what's happening now. There is a line. Let us say there is a line and we are having another line. You can see very clearly the inclination of these two lines is same because they are parallel to each other. Now the inclination of two lines will be same only when they are parallel to each other, because what's the meaning of parallel lines? That means the same line you are just displacing it to another position without without rotating it. You are just moving it, translating it, right? So that is nothing but the slopes are same for the parallel lines. So let's go to the next problem. Line through the points minus 2 comma 6 and 4 comma 8 is perpendicular to the line through the points 8 comma 12 and x comma 24. Find the value of x. So we can find out the slope of this line segment which is passing through minus 2 comma 6 and 4 comma 8, and also I know that if I am able to find out that slope, this slope, I mean the slope of this line segment and the other line segment product should be negative 1. So what we will do first, let's find out the slope of first set. So we have minus 2 comma 6, 4 comma 8. Let us say the points are A, B. So m of AB is nothing but equal to y2 minus y1, that is 8 minus 6, divided by 4 minus of minus 2. That's nothing but equal to 2 by 6 equal to 1 by 3. Now we have other 2 points. Let us say those points are C and D. We know C equal to 8 comma 12 and D equal to x comma 24. Now m of CD according to the formula is nothing but delta y by delta x, that is 24 minus 12 by x minus 8, that is equal to 12 by x minus 8. But we have been told that these line segments are perpendicular to each other. If we know that if two line segments are perpendicular to each other, then their product of the slopes is -1. So I can say m of AB into m of CD equal to -1, or 1 by 3 into 12 by x minus 8 equal to -1. I can simplify this 4 times. So that will give me 4 equal to 8 minus x, or x equal to 4. So the value of x is 4. If the value of x is 4, then the line segment AB is perpendicular to the line segment CD. We want to cross check that. We know the slope of AB is 1 by 3, so we should get slope of CD equal to -3. Substitute x equal to 4, you will have 12 by -4, that's equal to -3. So our solution is correct. So let's go to the next problem. Without using Pythagoras theorem, show that the points A, B, C are the vertices of a right angle triangle. We have 3 points A, B, C. Let me pick them. Let us say A is 0, 4, B is 1, 2. Let us say B is somewhere here, that is 1, 2, and C is nothing but 3, 3. So let us say that is 3, 3. So we have to prove that ABC is a right angle triangle. So that's how it looks like. So how to prove that this is a right angle triangle without using Pythagoras theorem? We know that AB is perpendicular to BC. We know that AB is perpendicular to BC. So if I am able to prove that m of AB into slope of AB into slope of BC is equal to -1, then I have proven that AB is perpendicular to BC. If AB is perpendicular to BC, one angle is 90 degrees, which is nothing but it's a right angle triangle. So let's go ahead and find out the slope of AB and slope of BC. What is slope of AB? Again we go back to our formula, y2 minus y1 by x2 minus x1. That's nothing but 2 minus 4 by 1 minus 0. That's nothing but equal to -2. Now what is slope of BC? Slope of BC is nothing but 3 minus 2 divided by 3 minus 1. That's nothing but equal to 1 by 2. Now if you multiply m of AB into m of BC, or nothing but slope of AB into slope of BC, is nothing but equal to -2 into 1 by 2. That's nothing but equal to -1. 2 cancels out, you will have -1, which implies that AB is perpendicular to BC. If AB is perpendicular to BC, then one angle of a triangle is a 90 degrees, which will tell us that angle ABC is a right angle triangle and right angled at vertex B. So that's how we can prove that without using Pythagoras, 3 points are vertices of a right angle triangle. If you take them and find out the slopes of AB, BC, CA, you will see that either AB is perpendicular to BC or BC is perpendicular to CA based on at which vertex the triangle is right angled. you can show that the slopes, product of slopes is -1, tells that those two line segments are perpendicular to each other. Let's go to the next one. Without using the distance formula, show that the points A, B, C, D, let us say these points are A, B, C, D. We have to prove that A, B, C, D are vertices of a parallelogram. Now we should not use the distance formula. So what is the definition of a parallelogram with respect to whatever we are working on now? As of now we are working on slope. So we know that two line segments are parallel to each other, then they will have the same slope. So a parallelogram will be set of two parallel lines. These two lines are parallel to each other. Again these two lines are parallel to each other. Let us say that this is A, B, C and D. If I am able to prove that slope of AB is equal to slope of CD, that implies that AB is parallel to CD. Similarly, if I am able to prove slope of BC is equal to slope of DA, that tells me that BC is parallel to AD. If you have two pairs of lines parallel to each other, then it is a parallelogram. So let's go ahead and try to prove this. So let's first try to plot these points. We have A -2 -1, so let us say -1 -2 -1 somewhere here. Okay, then we have and -3 2, so we have -3 and 2 somewhere here. Okay, then we have 4 comma 0, so we have 4 comma 0, that's another point. Then we have 3 comma 3, so then we have 3 comma 3. So we have to prove that these are vertices of a parallelogram. This is how it comes like. So let us take those points and say it is A, B, C, D. We know the coordinates of A, B, C, D. A is -2, -1 and B is, what's the B here? 4 comma 0 and C is 3 comma 3 and D is -3 comma 2. Now let's find out the slope of all of this, then we can finalize that whether AB is parallel to CD if the slopes are same. So we'll go ahead and find out the slopes. What is slope of AB? What is slope of CD? Similarly, what is slope of BC? What is slope of DA? Actually ABCD, BC and AD or DA. You can take anything. Okay, let's do that one by one. Slope of AB is nothing but equal to B minus y2 minus y1, that is 0 minus of -1 divided by 4 minus of -2, that's equal to 1 by 6. Slope of CD is nothing but equal to, if I start from D, y2 minus y1, that is 2 minus 3 divided by -3 minus 3, that's equal to -1 by -6, that's nothing but equal to 1 by 6. So AB is parallel to CD because the slopes are same, the AB is parallel to CD. Now let's go to M of BC, that is slope of BC. Slope of BC is y2 minus y1, that is 3 minus 0 by 3 minus 4, that's nothing but equal to 3 by -1, that's equal to -3. Let's go to slope of DA. DA is nothing but equal to -1 minus 2 divided by -2 minus of -3, that's equal to -3 by 1, that's equal to negative of 3. So slope of BC is equal to slope of AD, that gives me BC is parallel to AD. Now since the slope of AB is equal to CD, AB is parallel to CD, and slope of BC is equal to AD, BC is parallel to AD. So we know that two pairs of sides parallel to each other, it's a parallelogram. So that's how we can do some simple problems related to Parallel slope of a line is parallel and perpendicular. The point to remember, if two line segments are parallel to each other, then their slopes are equal. If two line segments are perpendicular to each other, then the product of their slopes is equal to -1. So see you in the next session, where we will go through angle between the lines and what's the formula with respect to the slopes. Thanks again. Bye for now.